Welcome to the On-Premise IT Roundtable, a podcast brought to you by Gestalt IT. On today's Roundtable, we're going to be talking about Intel and the future of network functions virtualization. This discussion comes from Intel's Cloud Day 2016. Discussing this today, we have Stephen Foskett moderating the discussion, Drew Conry Murray, Ryan Booth, Tom Hollingsworth, Matt Oswald, and John Welsh. Check out our show notes for links to all of their stuff at gestaltit.com/podcast.
So, Intel is best known not as a networking company, but as, the CPU people. That's very, very out of date. They are very much involved in all aspects of enterprise IT. In the networking space, one of the things that they're trying to do with their network builders is to get into more of the, to coin a phrase, network appliances world, right? Network functions and network function virtualization. So, Drew, maybe you can start off by introducing us a little bit to this concept of NFV and where you think Intel fits into that picture.
Sure. So a lot of things that Intel we're emphasizing today is the role that they can play in virtualizing network functions, so load balancing, switching, firewalling, that kind of thing. And hearing them talk about it, it's clear that they feel like there's an opportunity as more network functions move away from traditional switching and routing and hardware appliances out to the edge because of the whole network virtualization trend. There's an opportunity for them with their Xeon processor to start doing more actual packet processing. They're making a lot of initiatives there. They talked today about DPDK and a few other things. So I'm just curious what the group thinks about Intel's role here and what they're bringing to the table in terms of NFV.
Yeah, I think they make a strong play there, especially with the DPDK and how they're already ahead of that curve there, and then taking the virtual switch, sucking it in, handling all that stuff there, so you don't have to leave it. I think they have some interesting technology there, and they can leverage some good things.
So my question is around DPDK. The idea is to take a utility box on the edge and create specialized algorithms to do packet processing in whatever Xeon box happens to be on there, right? Mm-hmm. So how's that going to affect the network's vision, if you will, moving to things like commodity switches that are running, maybe more generalized CPUs and doing packet forwarding, then you have like a random ASIC to do something really, really specialized. With the way the chip design is going nowadays, can you see potentially in the future a switch that contains packet forwarding ASICs and like a slug of general purpose CPUs dedicated to allow NFV devices to run on a switch, not necessarily on a server platform?
Yeah, I mean, the performance numbers are really the big determiner of that. But just from an architecture perspective, I think it makes a lot of sense because ultimately, really, what we're doing with what Intel's been doing with DPDK sort of brings their chipsets up to the same standard that we've been treating companies like Broadcom and whatnot. Broadcom will come out with an SDK that switch developers can program against. This is really sort of the same thing. It's just adding their switch to that pipeline, and they're not new. So I think that's also something that you can look at. They're a big company.
Yeah, Intel's a pretty big company.
Yeah.
Fairly mature.
Yeah.
And I guess the question I have is, what does it do to your traditional networking vendors like your Cisco's and your Junipers, who are all signed on to that massive list of companies that we saw that are involved with DPDK and a lot of the other Intel network initiatives? Obviously, there's a play there, but what is it for them?
Arguably, I would say probably the same thing. You asked how would this affect them? I would say it would affect them in much the same way that Broadcom has affected them. A lot of companies, including Cisco, have taken the embrace and extend sort of portion of the strategy there, and I see no difference there. I mean, could we see a switch, Cisco switch in the future with leveraging more and more Intel hardware? Same kind of concept with Broadcom, probably. I guess it depends on what the customers ask for.
I absolutely think that that's the case because when you look at modern switch architectures from the last 24 months, almost all of them are running on top Trident 2 or Tomahawk. Mm-hmm. And so everyone's riding to that standard. Well, that makes Broadcom essentially the arms dealer of the networking world. And the problem is that gives Intel very little leverage in that area. I mean, it's arguable that Intel won the CPU wars for the servers and for the desktops, but the new battleground is in networking. So if Intel can get in there and get DPDK to be a part of what people are programming against, not just Broadcom, but with Intel's IP in there that gives them a real opportunity to displace in the next generation of switches, because they know what Tomahawk's capable of. Well, what happens when Tomahawk 2 is ready to come out? Maybe Intel can get you an extra 1 million packets per second, which would be pretty big leverage.
But I also think, I don't know if Intel necessarily is thinking about, maybe long term they're interested in going up against Brocade in like a top of rack switch kind of market, but the fact that virtual switches are going to way outpace the number of physical switches any organization is going to buy, I think Intel sees a lot of opportunity there to get a piece of that pie.
Mm-hmm. Yeah, and maybe that's another aspect of this is that if the physical network hardware isn't as important because the network is just connecting these big virtualized hunks, you can do an awful lot virtually.
Right.
And to me, I think that's where a lot of this is going to, the DPDK stuff's going to take it. It's going to be dumb, cheap switches on the infrastructure. They're stupid pipes, and all the intelligence is sucked into the hypervisor.
Mm-hmm. You just drove a stake into the marketing department of Cisco and everybody. They hate that big dumb pipe talk.
The problem is that the big dumb pipe still has to exist because,
right.
I mean, everyone loves the idea of completely virtualized software networking, but it's got to come out of an Ethernet cable somewhere, right?
Yeah, you have to have that physical connectivity to something, or it's not going to go anywhere.
Right. But in terms of growth, you're going to see a lot more virtual growth than you are the physical.
And I think, and this might segue into other stuff, but you still have to have those physical connections. You still have to have that. But at some layer or level, you have to be able to see the underlay. You have to be able to watch that traffic flow, be able to monitor it.
Why?
So once the traffic leaves a hypervisor and it dumps into the infrastructure, from that level, you have no visibility into those packets. It just passes through. So if you're talking through a VXLAN infrastructure, or if you're using GRE, however you're handling it, the infrastructure still needs to be able to see that traffic.
I would argue you need to see that traffic in your data center, but if this is running on top of Azure or AWS or Google Compute Engine, you don't care. It's two checkboxes that said, let this talk to that, and the packets can go any way they want through the underlay network of the cloud provider. As long as they arrive over here in the right sequence, I don't care.
That's a good point.
That's interesting. So in the cloud, does the physical network necessarily have to be a big dumb pipe?
Taking a quick intermission here to let you know that if you're enjoying the discussion, head on over to gestaltit.com. We've got coverage from across the enterprise, from virtualization and servers to networking, storage, and even that newfangled cloud. While you're there, sign up for one of our newsletters, and you'll get the latest coverage right in your inbox. And if you haven't already, subscribe to the On-Premise IT Roundtable in iTunes or your podcatcher of choice. All right, let's get back to the discussion.
Is there a place for advanced network hardware in the cloud?
I would say yes, but I don't think you're going to see it.
So the service provider has advanced networking hardware, but the customer never interacts
Yeah, the
with that.
customer's just going to define, this is where I need traffic to go, this is what I need it to do, and all that stuff on the back end is going to be done by them without, because they don't want you messing with their network. They want their network to work a certain way and give you parameters that you can modify to make it do what you need it to do.
Now, I think what you're going to see is you're going to see cloud providers that are trying to offer custom specialized hardware as an offering, give you an opportunity to do, well, you're not going to see what's happening, but you're going to give them, like, I would like to send the traffic from this VM to a crypto accelerator or to an SSL VPN terminator. And so you click the box that says, I want this to go here. But what actually happens is there's a service chaining instantiation inside the cloud that redirects the traffic to a pod that contains, like 10 of those. And then they can keep track of who's using that, because then they have all the analytics they need to say, well, we have 2,000 customers that are using the crypto accelerator boxes, billing appropriately. And that's where the specialized hardware is going to come into play, I think.
Well, and to some extent, don't they already have a little bit of that with, like on AWS, the AWS Marketplace, where you can deploy services, like there's an F5 service that you can deploy to do some security in line with your with your instances that are running there.
I think they are, but I think that's all NFV related. It's all software. So when you click the box for a WAN accelerator, then a WAN accelerator software appliance deploys on that box. I'm talking about things that still have to run in hardware. We just got out of a session where they were talking about doing RSA nonce stuff, which is still ridiculously hard to do on a general purpose CPU. They have to build custom ASICs to do that because they're just designed to go as fast as they can go.
I think you have to be very careful about that with respect to scaling out your cloud if you decide to leverage hardware resources like that, hairpinning essentially at a load balancer or anything like that. I'm not going to say that there aren't special cases, but you just have to think of it from just a design perspective, like how can I generalize my services in such a way where I don't have to do that? I tend to take that kind of thought as maybe an indication to go back to the drawing board, because if you've fallen into that, I need to pipe all this traffic through this box, this physical box to do the services that my customers are asking for. We're seeing a lot of those services move into the hypervisor itself or into virtual machines, right? We use F5 today. Tomorrow, more and more folks are just going to be using HA proxy, and because the features they want aren't actually that sophisticated, they want basic stuff, and it's not really that big of a pill to swallow for the basic stuff.
The On-Premise IT Roundtable is once again brought to you by Gestalt IT, home to IT coverage from across the enterprise. Make sure to follow us on Twitter at Gestalt IT and at facebook.com/Gestalt IT. Very original. The On-Premise IT Roundtable is produced by Rich Straffolino. That's me! Until next time, from all of us here at Gestalt IT, have a super sparkly day.